Halogen compounds. Preparation of methyl iodine from methyl alcohol and phosphoriodine. In a 200 centiliters round bottom, the flask place 15 grams of methyl alcohol and 3.2 grams of red phosphorus. Ready a refill condenser with cork attached. Place the flask in cold water and add a small portion at a time. 13.8 grams of iodine, and the addition should take about 10 minutes. If the contents of the flask begin to boil, attack it to the reflux condenser. When reaction ceases, add more iodine. Finally, attach the flask to the condenser. Let it stand for at least 4 hours, preferably overnight. Stir throughout. A condenser from a water bath as long as any liquid passes over. The receiver should be placed in cold water, as methyl iodine is very volatile. Wash this distillate by decantation with diluted aqueous solution of sodium hydroxide until the lower layer is colorless, and then once with water. Separate the methyl iodine carefully from the water using a separator funnel and transfer it to a small distilling flask at about 10 grams of anhydrous calcium chloride. Stop the flask. Place a cork over the end of the side arm and set aside until the liquid is quite clear. Place a thermometer in the flask, connect the latter with a condenser, and distill from a water bath. Note the boiling point and weight of the methyl iodine. Calculate the theoretical yield from the iodine used with iodine, because it's right, and the percentage of is obtained. Methyl iodine boils at 14.4 degrees and has the specific gravity 2.27 at 15 degrees. The yield in the sperm should be about 18% of theory. Note that an excess of the alcohol is usually taken in preparing alkaline halts by the method illustrated above. The phosphorus and iodine are used in the proportion necessary to form phosphorus 3 iodine PE3. The chief reaction which takes place. The chief reaction which takes place is presented by the following equation. 3CH2OH plus phosphorus plus 3 iodine gives 3CH3 iodine plus phosphorus OH3. The hydroiodic acid which is involved is produced as a result of side reactions which are described in the case of phosphorus through chloride in the previous paragraph. Property of methyl iodine. Methyl iodine under light. Place in each of 2 small test tubes 2 centiliters of methyl iodine. Close the tube tightly with corks. Put one tube in the desk in the dark and allow the other to stand in the sunlight. And at the end of an hour or two, examine the 2 tubes to remove the iodine set free. Add a drop of mercury, some copper when shakes the alkyl iodines. Iodes should be kept in well-stoppered bottle of brown glass, methyl iodine and silver nitrate. To a few drops of colorless methyl iodine suspended in water, add a solution of silver nitrate and shake. Repeat using a solution of methyl iodine in alcohol and of silver nitrate in alcohol. As far as methyl iodine, sodium hydroxide are concerned, shake occasionally during half an hour with a mixture of 1 centiliter of methyl iodine and 5 centiliters of a dilute solution of sodium hydroxide. At the end of this time, neutralize with dilute nitric acid filter and test a part of the filtrate for methyl alcohol according to experiment 77b, page 15.5, and a part for an iodine. For other reaction of alkyl halides, see the experiments with ethyl bromine below. Preparation of ethyl bromine from alcohol, potassium bromide, and sulphuric acid. Add a mixture of 16 grams of alcohol and 15 centiliters of water contained in a 1 liter flask. 100 centiliters of concentrate sulphuric acid cooled through hotly is in running water and Add 100 grams of fine powdered potassium bromide. Connect the flask by means of a bent glass tube and a rubber stop with a long condenser throughout which a rapid stream of water is passing, and fit an adapter by means of a cork to the end of the condenser. Use after 300 centiliters Ellen Meyer flask as a receiver and place it in a beaker about 1/2 full of cold water. Fill the receiver up full of water and adjust the condenser so that the end of the adapter is below the surface of the water. These precautions are taken because ethyl bromide is a very volatile liquid. Boiling point 13-19 degrees. Place a stand bath under the flask containing the reaction mixture, heat with a large flame, and distill as rapidly as possible. As distillation proceeds, the ethyl bromide drops to the bottom of the receiver, and add the aqueous part of the distillate. Finally, overflow into the beaker. Distill until drops of the insoluble bromide cases to appear. About 1 hour is required for distillation. If it's carried on rapidly, decant off most of the water from the ethyl bromide into a beaker. Add a dilute solution of sodium hydroxide. Shake and decant. Wash again with water and transfer to a separate funnel. Run off the lower layer into small dry distilling flask. Add an hydrogen chloride, about 1/4 of the volume of the bromide, and close the flask tightly with cork. Set aside until the liquid is quite clear and the drops of water are visible. If the calcium chloride appears moist and set aside again. Connect the flask with a long condenser. Use a receiver, a dry flask surrounded by ice water, distill from a water bath, and collect the portion which boils at 35 degrees, 14 degrees. Calculate the theoretical heat from the potassium bromide used. From the bromide and the percentage yield obtained. Write the equation for all reaction. Why does the solution turn red during the heating? Ethyl bromide boils at 13.8.4 degrees and has the specific gravity of 1.47 at 13 degrees Celsius. The yield in this beverage should be about 18%. Of the theoretical. Note that ethyl bromide prepared in this way contains a small amount of ether from which it cannot be separated readily by distillation, since ether boils at 13.5 degrees, ethyl bromide at 13.8.4 degrees. In separating the two substances, advantages is taken of the fact that ether is soluble in cold concentrated sulphuric acid, while ethyl bromide is not soluble. The bromide prepared by the method given above can be purified by adding its slowly constant shaking to an equal volume of concentrated sulphuric acid kept cold by immersion in ice water. After this treatment, the liquids are separated and the ethyl bromide shaken with water, dried, and distilled. Properties of ethyl bromide. Ethyl bromide and solubility. Using about 1 centiliter test determine whether ethyl bromide dissolves in the following liquids: water, alcohol, ether from petroleum ether, and cold concentrated sulphuric acid. Test the ethyl bromide for halogen with a copper wire. Shake about 2 centiliters of ethyl bromide with 5 centiliters of water to remove any free hydrobromic acid which may be present. Separate the bromide by means of a pipette and dissolve it in 5 centiliters of an alcoholic solution of silver nitrate. Is silver bromide precipitated? Yes. Open the test tube and allow it to stand until the next laboratory exercise. Is silver bromide precipitated? Compare with that obtained with methyl iodine. Ethyl bromide and alkyl potassium hydroxide. Shake a small piece of potassium hydroxide with 10 centiliters of absolute alcohol filter of the liquid and dissolve it in 2 centiliters of ethyl bromide. Boil for 1 minute. Dilute with water. Acidify with a dilute solution of pure nitric acid and another solution of silver nitrate, ethyl bromide, and magnesium. Just cover the bottom of the test tube with magnesium powder. Add 2 centiliters of ethyl bromide, 2 centiliters of ether, and a very small piece of iodine. Place the tube in warm water for 1 minute. Cool and add a little water. Ethyl bromide and sodium to 5 centiliters of ethyl bromide in a dry test tube. Add a piece of sodium the size of a pea. Close the tube with a cork carrying a small dry tube containing calcium chloride and set aside. Examine 1 hour. And note some Tetrahydrides are decomposed when treated with concentrated sulfuric acid. The reaction is useful as a test to distinguish alkyl aldehydes from certain halogen derivatives of benzene and other hydrocarbons which are not decomposed readily, and by alkyl potassium hydroxide it is necessary to use a solution of potassium or sodium hydroxide free from halogen compounds. Since the alkalis usually contain chlorides, the solution is prepared by using an absolute alcohol in which sodium chloride and potassium chloride are insoluble. Preparation of ethyl iodine from methyl alcohol and Hydroiodic acid. Place 16 grams of strong solution of hydroiodic acid and water content boiling mixture with content 5.7% hydrogen iodide and as the specific gravity 1.7. In a 200 centimeter distilled flask, connect with the condenser throughout which a stream of cold water is passing, connected an adapter to the condenser and use as a receiver flask surrounded by water. Close the distilled flask with a stopper bearing drop-in funnel, the end of which reaches the bottom of the flask. Heat the acid boil and drop it throughout the funnel 10 grams of alcohol to about the same rate as that of which the iodide distills over about 1 drop per second. Add water to receive a shake and decant of the water into a beaker. Separate the iodide by means of a separation funnel. Place it. Preparation of normal butyl chloride in a 500 centiliter flask. Dissolve in 95 grams of concentrated hydrochloric acid, 155 grams of nitrogen chloride. Keeping the mixture cool to avoid loss of hydrogen chloride. Add next 13.7 grams of normal butyl alcohol and connect the flask to a reflux condenser, or preferably use the form of Bertus represented in figure 17, page 72. Boil the mixture gently for 1 hour. Separate the upper layer and place it with about an equal volume of concentrated sulfuric acid in a distilling flask. As I remember the latter is closed by a cork and the neck connected with a return condenser. The mixture is cautiously heated so that the chloride boils gently. At the end of 1/2 hour, distill the chloride using a water condenser. Wash the distillate with a dilute solution of sodium hydroxide, separate it, and place it in a small distilling flask with a little hydrogen chloride. Stir for a while and still collecting the portion boiling at 76-78 degrees. Weigh the chloride and calculate the percentage yield, which should be about 66% of the theoretical based on the weight of alcohol used. The number of butyl chloride boils at 78%, and has a specific gravity of 0.907 at 0 degrees. It has been shown recently that alkyl chloride can be prepared from alcohols and hydrochloric acid in the presence of water, provided zinc chloride is present. The metallic chloride probably acts as a catalytic agent and not as a dehydrating agent, hence has been assumed in the past. During the reaction, a part of the alcohol is converted into polymerized products, which are removed from the chloride by distillation. Those products are destroyed by hot concentrated sulfuric acid. Preparation and properties of chloroform. Place in a filter flask 115 grams of fresh bleaching powder and 400 centiliters of water. Shake vigorously in order to break up the lumps of bleaching powder and connect the flask with a reflux condenser. Throughout the condenser, add drop by drop from a separated funnel mixture of 12 grams of acetone and 5 centiliters of water. Arrange the flask for distillation with steam and distill as long as the chloroform comes open. Wash the chloroform by decantation twice with water, separate and place it in a small distilling flask with anhydrous calcium chloride. When the liquid is quite clear and no drops of water are visible, distill from a water bath using a condenser. Weight the product, determine its specific gravity, and calculate the percentage yield obtained. Chloroform boils at 61 degrees and has a specific gravity 1.498 at 15 degrees. The yield should be about 20 grams. Odors and solubility of chloroform. Note the odor of chloroform and determine whether it is soluble in water, ethyl alcohol, petroleum ether, and sulphuric acid. Determine if the following substances are soluble in chloroform: iodine, butter, Vaseline, olive oil, and a bit of black rubber tubing. In the latter case, let the liquid stay in contact with the rubber for some time, then pour out the liquid onto a watch glass and let it evaporate. Try to ignite some chloroform, light a match and pour on the flame and the vapor from some chloroform which has been heated to boiling. Apply the test for a lantern with a copper wire. Shake some chloroform with a little water and test the aqueous solution with silver nitrate. If silver chloride is formed, wash the chloroform until the water no longer reacts with silver nitrate. Separate the chloroform with pipettes, dissolve it in alcohol and add alcoholic solution of silver nitrate. Place some chloroform which contains no free hydrochloric acid in the test tube. Close the tube with a stopper and allow it to stand several days in a place where it will be in a strong light. Note the odor, shake with water and test the aqueous solution with silver nitrate, chloroform and sodium hydroxide. Heat a few drops of chloroform for 1 minute with about 5 cl of very dilute solution of sodium hydroxide free from chloride. Test half of the solution for chloride and neutralize carefully the rest of the solution with chloric acid and 5 drops of dilute solution of mercury chloride and heat. Carbamyl reaction. Warm together 1 drop of aniline, which is primarily amine and as the formula C6H5 and H2, 1 drop of chloroform and 1 cc of an alcoholic solution of potassium hydroxide. On account of the very disagreeable odor produced, the test tube should be washed in the hot with concentrated hydrochloric acid, oxidation of chloroform. Heat together a few drops of chloroform, a small crystal of potassium bichromate, and 2 cl of concentrated sulphuric acid. Should note the odor of the gas formed and note the heat of chloroform is affected gently by the quality of the bleaching powder used. The acetone is slowly as the reaction is vigorously one of and fronting is apt to occur. If the flask becomes hot, the reaction between chloroform and sodium hydroxide is analogous to that between the alkali and other halogen compounds. In this case, therefore, chlorine atoms are replaced by hydroxyl groups. The resulting compound loses water and formic acid is produced. Chloroform and sodium hydroxide. Heat a few drops of chloroform for 1 minute with about 5 cl of a very dilute solution of sodium hydroxide free from chloride. Test half of the solution of chloride. Solution for chloride, neutralize carefully the rest of the solution with hydrochloric acid. Add 5 drops of dilute solution of mercury chloride and heat. Carbamyl reactions. Warm together 1 drops of aniline, which is a prominent amine, and has the formula C6H5NH2, 1 drop of chloroform and 1 cl of an alcoholic solution of potassium hydroxide. On account of the very disagreeable odor product, the test tube should be washed in the hood with concentrated hydrochloric acid. As far as oxidation of chloroform is concerned, heat together a few drops of chloroform, a small crystal of potassium bichromate, and 2 cl of the concentrated sulphuric acid. You should note the odor of the gas formed. The heat of chloroform is affected greatly by the quality of the bleaching powder used. The acetone is added slowly, etc. Preparation of ethyl bromide. With everything into a 200 cl distilling flask, 20 grams of phosphorus pentoxide. Close the side arm of the flask with a stopper and connect the flask with the reciprocal condenser. Place the flask in cold water and with constant shaking and slow throughout the condenser. 13 grams of alcohol. Heat the flask carefully with a free flame until the phosphorus pentoxide is dissolved. Remove the condenser. Place the flask on where it goes at such a heat that it can be heated with a burner. Close with a stopper and connect with the absorption apparatus, which is arranged as follows: fit 3 8-inch test tube with tightly fitted stopper in each.